Today's lesson is 4.6, complex numbers. Whenever we have a square root of a negative number, let's call it a, we can start thinking of it as an imaginary unit. So when we have the square root of a negative number, we can start thinking of it as -1 times whatever that number a is. So I'm going to separate it into -1 times 3, -1 times 17, whatever it is. Then I can start thinking remember, square roots work as the square root of -1 times the square root of whatever that number a happens to be. Well, this square root right here, this negative square root, is what is called my imaginary number. So this becomes the imaginary number I, and then of course I work with my square root of -a. And of course the times doesn't have to be there. So just a quick reminder, the square root of -1 is always going to give you your imaginary unit I, and whenever you take I and you square it, you get the number -1. Okay, let's go ahead and simplify each of these numbers by using my imaginary unit I. So whenever I see the square root of a negative number, I always think about it as -1 times that number. So there's where you're seeing that -1 times a. Then I can go ahead and think of it as this. And what I would actually put in any type of calculator would be the square root of 13. Am I going to get the square root of am I going to get a whole number, or am I going to get a decimal? In this case, I'm going to get a decimal, so I'm going to leave it as the square root of 13. This would be my complex answer. Okay, you want to put the I first because you don't want to think of the I as being underneath the square root. Okay, let's take a look at the next one. So same thing, -1 times 16, the square root of -1 times the square root of 16. The square root of -1 is, of course, I. The square root of 16 is 4. Now, we don't commonly see it written as I4, just like we don't see it commonly written as X4. We switch them, and we normally see it as 4I, very similar to 4X, okay? There we go. And of course, our last one, I do believe this is oh no, there's two more. The next one, you guys kind of got the idea, right? You split them. You split it into -1 times the number, then you split it into the square roots, and then of course, we can think of it as times that the square root of 81 is 9, and then we just take and we switch them and put the 9 first. Its square root goes after a whole number in front. You guys might get really good at it, and you might start thinking, well, I can just go ahead and do this, miss. And of course, yes, you can. Once you get really, really good at simplifying, this is, of course, what I would want to see you do. Now, the square root of 30, if I were to break it down, I could think of it as 3 times 100, and I can think of 100 as 2 times 50, and I could think of 50 as 2 times 25, and I can think of 25 as 5 times 5. When I am simplifying this, remember any two numbers that have a pair, right? These guys are out. They pair up and become, let me put it over here, 2 times 5, which is 10. And this one gets left underneath the square root because it doesn't have a partner, right? Simplifying the radicals. If this is the case that you have an answer like this, the whole number comes first, then the imaginary part I, and then you put the square root after. Okay? All right, let's move on to adding and subtracting. So the next thing we're going to go ahead and do is we're going to add and subtract, find the sum and the difference of each one of our numbers. All we have to do is take and put the real part with the real part and the imaginary part with the imaginary part. That's all we have to do. So I'm going to come in here and I could rearrange these. Okay, I could rearrange these into my real parts, 7 plus -5, and then my imaginary parts would go in the other, 3i plus 5i. And then, of course, remember, don't forget to take the signs in front of any of them. Then I can go ahead and do my sum from my real part. I get 2. And then do my sum from my imaginary part. I get 8i. And this would be my answer. Okay, so let's try it one more time. Remember, you're going to do your real parts plus, and then you're going to do your imaginary parts. Sorry, I just called them fake parts. Sometimes it might make sense to leave the plus in between them out and more think about them as the real portion. Think about them as adding the real, and then think about them as adding the complex. Okay? Because sometimes the addition of my complex could actually be a negative, and so then I'd want to have a minus. I'd want to have a minus in between. Okay. All right. So I have -3, and then I have +8 for my real part, and then I have 1i. Notice what I did there, right? 1i plus -7i. Okay, 1i plus -7i. So -3 plus +8, or 8 minus 3 would give me 5, and 1 plus -7 would give me -6i, and that would be my answer, even though I'm adding, right? I don't need to think of there being a plus here. I don't really need that to be there. So I'm going to go ahead and get rid of that there. Now we're just going to go ahead and change into subtraction. So the only thing I'm doing here in the last two examples is I'm changing it into subtraction. Now this case, I need to be a little bit carefuler. I do need to be a little bit more careful because I am subtracting. Okay, so I do need to be a little bit more careful. But the same thing goes. 10 minus 4 is for my real part, right? That's all I'm doing. I'm going to do the reals minus each other, and now I'm going to do the complex. I know I'm adding it up there. Okay, so I have +3i minus -1i, right? Because that's what this one says here in the complex. Okay, and of course these blue ones are my reals, just like they have been. Oops. Now I'm going to go ahead and do my subtraction. So 10 minus 4 gives me 6. And then 3i minus a -1. Minus a minus is going to turn to a plus. So I have +4i because I had a +4 for 3 plus 1. And I just kind of tags along just like an x value would. And there you go. All right, let's try the last one. Okay, we're going to do the reals and we're going to do the complexes. -4 minus 5. That's -9. Now let's do the complexes. -2i minus, it's +6i. So notice I'm not changing this minus. This minus comes from this one that I put in my pink highlighting. Um, it is positive right here. Notice what happened in the last one. I had double negatives. I had a negative here and a negative here, and that's why I got the positive. So just be very careful. All right, -2 minus 6 would give me -8, and I just tags along like X. All right, so now we've seen how to simplify, we've seen how to add, we've seen how to subtract. Let's go ahead and talk about how to multiply. We're going to start very simply with multiplying 5i times 3i. Okay, you're going to do the same thing. You're going to take your reals, you're going to take your real parts, and you're going to multiply them times each other. And then you're going to take your imaginary parts, the complex parts, and you're going to multiply them times each other. Our real parts, our real parts this time would be just the 5 and the 3. So you're going to do 5 times 3. That's 15. Okay, and then your complex part or your imaginary part is I times I. I times I is I squared. But remember at the very beginning on the first slide, we talked about I squared is really the number -1. So we have 15 times -1 or -15. And that would be our answer right here. Okay. Now this happened, of course, because we had I times I. And whenever you have I times I, this is going to happen, and it's going to change the sign of whatever number's in front of it. So had that 15 been negative, of course, it would change to a positive. All right, let's take a look at the next one. In the next one, what I'm going to go ahead and do is I'm going to distribute. I'm going to take my 4i and I'm going to distribute it. I'm going to take my 4i and I'm going to distribute it. Okay, let me back that up a bit. Let's start right here. 4i times -3. Well, you would do 4 times -3. You would do 4 times -3, and you would get -12. And since the 4 has an I, you would think of it as -12i. Plus, because that is what's right here in your parentheses, you're going to go ahead and multiply again. You're going to think 4 times 2, 8, and then you're going to think I times I squared. Okay, now you're going to go ahead and you're going to look at this multiplication and you're going to say, I see an I squared. And I know from the last one that when I see I squared, it's really -1. So this is really -12i plus 8 times -1. Well, that's really -12i minus 8. It's not common to see the answer written in this form. We normally see the real part first. We normally see the real part first, and we see the complex part second. So all we have to do next is just switch these two. The negative comes with the 8, and then the negative stays with the 12i, and they would switch places, and there's our answer. All right, the last one I want to show you is multiplying when you have a double distributing, okay? Multiplying with double distributing. What I would really suggest that you do is make the box and multiply using the box method. With the box method, you need to have 2 of them for the 2 plus the 7i. And notice I didn't put the plus, but I very well could. I'm going to come back and make it nice and faint for you. Okay. And then you want to make 2 along the other side for the 4. And this time I want to make sure I know it's -5i. Okay, because it does say -5i, so I want to make it negative. What I'm going to do is I'm going to multiply whatever number's here, which is 4, times whatever number's here, which is 2. So I do 4 times 2, 8. You know how rectangles work. If this is 4, so is this. So for the next one, I have 4 times 7i. Well, 4 times 7 is 28, and the I would just tag along, okay? -5i times, remember, we know how rectangles work. If this is 2, this is 2. So -5i times 2 times 2. That would give me -10i. And then, of course, the last one, if this is -5i, this is -5i. If this is 7i, this is 7i. So I have -5i times 7i. -5 times 7 is -35. I times I is I squared. Now I'm going to go ahead and I'm going to start putting things together. I always start in the upper left corner. I always start right here. These two terms right here are like terms. And what I like about the box method is the box tells me, hey, add me together. It's right there in the box. And then this one will come last. Okay, so I'm going to start with the 8. Then I'm going to go ahead and I'm going to add these two together. Since they're both complex, I'll go ahead and do that. I'm going to add those two together. So 28 plus, right? I'm adding them together just like the box is telling me to do. Plus negative 10 would give me positive 18i, and then minus 35i squared. Now I just have to take care of my I squared and make it become negative 1. So 8 plus 18i minus 35 times negative 1. 8 plus 18i plus 35, because negative 35 times negative 1 is positive 35. And then, of course, I can take my two real numbers right here, 8 and 35, and I can go ahead and add them together, or I can combine them, of course, for my final answer of 43 plus 18i. All right, we've added, we've subtracted, we've multiplied. The next one is to go ahead and divide. The next one is to go ahead and divide. So let's go ahead and write each quotient, which is my dividing, as a complex number. What I don't like about this problem is that I have the complex variable I in the bottom of my fraction and in the bottom of my division, and I don't want that. So to get rid of it, I'm going to multiply by a fraction. Okay, I want to get rid of the 2i. So if I place it here, right? If I place it here, these two will cancel each other out, right? They would cancel each other out. That's not exactly what I want to do, but I just want to let you know that that's why I'm thinking this. If I were to leave it just like this, I would change my problem. And so what I'm going to do is place 2i over 2i, because think about it. 2 divided by 2 is 1. So 2i divided by 2i would also be 1, right? And so I'm not really changing this because I'm just multiplying by 1. I'm just making it very fancy. Okay. Now I don't want to start doing what I just did, because if I did start canceling, right, I would end up with the same thing, right? If I cancel, I end up with the same thing because I've added the 2i to the bottom. You can't just not add the 2i to the bottom. It doesn't work that way, because if I did that, then I'm changing this. Okay? So what I'm going to do is I'm going to say, well, the top needs to do this. And we see that distributing that we saw on the last slide. And the bottom looks like this. And we saw that in the very beginning on the last slide as well. So next I'm going to go ahead and I'm going to distribute on the top. 2i times 8 gives me 16i plus 2i times 10i gives me 20i squared. And on the bottom, I have 2 times 2, 4, I times I squared. Okay. Now remember this I squared, is really, maybe let me make it this. This is really negative 1, and this I squared is really negative 1. So what I really truly have here is 16I minus 20, because 20 times negative 1, right? 20 times the negative 1 gives me negative 20. And on the bottom, I have negative 4. Okay. Now what I'm going to do is I'm going to go ahead and take the top and I'm going to switch these two, and I'm going to see, can I divide 16 by 4? Can I divide 20 by 4? Okay. So the division takes a little bit. It's a lot of extra steps. But I'm going to go ahead and I'm going to say negative 20 divided by negative 4. plus 16i divided by negative 4. So negative 20 divided by negative 4 would give me positive 5, and positive 16i divided by negative 4 would give me minus 4i, and there is my answer. Let's see that one more time. Let's see that one more time because that was tough. Now notice here. Here I have something a little bit harder, and remember it's always the denominator in a division problem that you would like to get rid of. So what you're going to do is you're going to multiply this, not times itself, but times its opposite. And you're going to see why I chose the opposite in just a minute. So because it had a minus, I want to make sure my top and my bottom have a plus. Okay, I need to make sure they have a plus. Okay, on the top, I would have 6 times 2 plus 3i. On the bottom, I'm going to have 2 minus 3i times 2 plus 3i. Now on the top, I am in the numerator, I'm simply going to just distribute. So I'm going to get 12 plus 18i. In the denominator, in the bottom of my fraction, I'm going to go ahead and I'm going to make my box again, where I put 2 minus 3i, and then I cut it into 2 more, 2 times 3i. Right? So I cut it into 2 boxes in each direction, top to bottom and left to right. Okay, remember you're doing 2 times 2, 4. If this side of the rectangle is 2, so is this side. So 2 times negative 3i. Right? You guys got it? 3i times 2, because this side and this side are the same. And lastly, 3i times negative 3i. Okay, so that would be negative 9i squared. Remember, these two right here are going to get added together. And this is exactly why I did this. 6i plus negative 6i cancel each other out, and my imaginary variable of I is gone. In the last one, you might be thinking, but the I is still there, but look, it's I squared. And remember, we know that I squared is really negative 1. So this on the bottom is really 4 minus negative 9, or 4 plus 9, and it becomes a whole number. So I have 12 plus 18i in the numerator, and in the bottom, I have 4 plus 9, 13. The last thing I'm going to do is check, does 12 divide by 13? No. Just like the 20 divided by the 4, it did that in the last one. 12 and 13 is going to stay 12 over 13, and 18 over 13 is going to as well. This is my final answer. All right. How can I use this with quadratics? How can I use this with quadratics? Well, I can use this to actually help be solved. So remember, we can think of this as A, right? And we can think of this as B. And we can think of this last one as C. Okay? So what I want to show you just really quick is I could think of this as 1 times 2, and I could put my x's with it, right? And then I can think of 5 as 1 times 5. So let's just see really fast. X and 2x, 1 and 5. Can I actually factor this? So I get 5x and I get 2x. I have to have the same sign, right? I would have to have the same sign. So that means I have positive times positive, or I have negative times negative. Since my A term, let me grab my pink, since my B term is negative, A negative plus a negative is going to give me a negative. So they have to both be negative. So I could go ahead and I know that both of these are going to be minus. I add them together, I get -7, but I want -3, right? I want -3. So let's switch them. Maybe if I switch them, it will work because remember we said that was what we could do, right? But remember, they both have to be negative. They have to. So I get -10x when I do 2 times -5, and I get -1x, and I add them together, I get -11x. This is just not factorable. So what I'm going to do now is erase all this stuff because I can't factor, right? I can't factor. I just wasted a bunch of time. No, I didn't. Not really. Because what I can do now is I could use the quadratic formula. Whenever I can't factor, I use the quadratic formula. So x equals -b plus and minus the square root, b squared minus 4ac all over 2a. So let's go ahead and grab in our colors here. And I just happen to have those two right there. So let me do that. And there we go. Now I can go ahead and start filling out my answers, right? And I like to, remember, I like to make my skeleton because it helps me to put in my numbers faster. I'm going to go ahead and fill it out as best I can in order. So there's my -3s because my pink B goes first. Then comes my A, 2, and of course the A goes again at the bottom. And then let's go ahead and fill in our C, 5. Right here, I see 2 negatives, so I'm going to go ahead and say I have +3 because 2 negatives make a positive. And if I do the discriminant, this part here is called the discriminant, I can go ahead and see that I get -3 squared is 9, 4 times 2 times 5, 10, that's 40, and I end up with -31. And 2 times 2 is 4. Now, in the past, what we would have said is we cannot do this. There is no real solution. And that is true. There is no real solution, right? We know there is no real solution, but now we know there's something called a complex solution. Right here, I can go ahead and split this into the square root of -1 times the square root of 31. And I can think of this as, right? I can think of this one, let me go ahead and grab this. I can think of this right here as -1 times the square root of 31, which I know is I square roots of 31 divided by 4. So here would be my two answers right there. You're not going to be able to put this into any kind of decimal. All you're going to be able to do for Alex is to take this and split it. You would write your fraction once with 3 plus I, square roots of 31 over 4, and then you'd write it comma a second time, 3 minus I square roots of 31 over 4. All right, see you guys next time.